let's get started. Whoops, what is it? Wants access to control. Okay, so today we are going to be finishing up with exception handling in C and C++, and then getting started with information management. And again, the reason we have it here in the class is that ABET requires us to make you familiar with information management before you graduate. And while we have a course, Databases and Scripting Languages, it's an elective course. It's not a required course. So somewhere in our required curriculum, we need a kind of section on information management. And so 365 is programming languages and systems. So it's actually not just a survey of languages. It's also supposed to be a bit about systems. About 10 years ago, it was about compilers. Then it was kind of about graphical user interfaces. Now, for about 3 weeks, it will be information management. And you actually will kind of learn, well, not a lot, but a bit about some languages like SQL, HTML, XML. You can say, quibble whether the languages, but they are called, some of them, like HTML, XML, are called markup languages. So you're still learning something about languages, but I will concede it's a little bit different. And the information I have kind of composed for the next 2 days came from a lot of different sources. There's no textbook on it. There's just no real good source of information other than my notes. So when you do homework 7, which is about information management, you're pretty much going to have to rely on my notes for part of it. Once we get to HTML and the like, plenty of outside references, but kind of the introductory material is stuff that I compiled. It's why I made attendance mandatory for today and Tuesday. Also, there is an exam coming up. It is a week from Tuesday on March 5th. And if you go to the sample exams, you can find that there is sample exams from spring 2016. And someone said, but you used to have more exams there. Yes, I used to have more exams there. And what I found was students were only studying the exams. They wouldn't study anything else. And then I'd give, of course I don't give the same exam. I would give other kinds of questions, and they'd completely bomb the questions and then tell me, yeah, well, I only studied your exams. So since that time, I now only give you one set of exams so you can see what my style is, but you won't think, oh, that's just what he's going to do. You're going to have to study the material. And I will have a review sheet that I'll be putting out next week that should help you as well. So I'll take more questions about the exam on Tuesday. Today's kind of a busy day, so I am going to dive into the lecture today, and then Tuesday I can take some questions on the exam. Of course, you're free to post to Piazza too if you want to get started studying on it early. So we're going to talk about exception handling in C and C++ today. And turns out that exception handling in C++ is not all that much different from exception handling in Java. So I'm just going to go over the differences. The Java folks borrowed the try-catch construct from C++. It originated in C++. So it has the same basic form of try-catch with a single formal parameter, which is the type of the exception object. The type of that parameter can be a primitive type. So in Java, it could only be an object, but in C++, that formal parameter is allowed to be an integer. So for example, you could simply define integer codes for your different exceptions if you wanted to, and make the formal parameter be an integer. Now, if you want to carry additional information about the exception, then you'd probably need to create a object to do that. In C++, there is no object at the top of the quote, exception hierarchy. So they have a default way of catching any exception, and it is ... with no spaces. So it should be the last catch statement, because if it's earlier, it matches anything. So anything you'd put after the catch ... will never be caught. It'll never match. So just like in Java, you should put your more specific parameters first, your more general parameters last, and ... is the most general of all. Unlike Java, C++ does not have finally. So there is no finally in C++. This is something that Java added, very helpful for cleaning up, closing down resources, but there's no finally clause in C++. Okay? Just like in Java, execution resumes after the try-catch block. So if the try block exits normally, execution picks up right here. If it throws an exception and is caught, say, by this catch statement, and the catch statement handles it without rethrowing, execution picks up here. As in Java, anything defined inside the try statement goes out of scope as soon as the try statement exits. That includes a throw out. So anything declared in the try statement or try block goes out of scope as soon as the try block exits. And that includes if you do a throw. And what that means is that anything you declare inside the try block is not accessible in the catch blocks. So if I have declared int a right there, a is inaccessible down here. A is undefined because you're already out of scope with respect to that try block. Okay? So questions about that? This is all pretty similar to Java. Unlike Java, you can actually ignore the formal parameter. So you can provide a type. For example, you could say bad Alec, which is a type of predefined exception in C++, and then not provide a name for that formal parameter. And that way you'd be able to match the type, but if you don't plan to use the parameter in any way, there's no reason that you have to provide a variable name. That's different than Java, where you always must provide a variable name. Okay? Now, the big difference between Java and C++ is this is really bad practice in C++. Okay? Do not throw exception objects off the heap. Okay, you do that, of course, in Java because all objects come off the heap. But in C++, you have to garbage collect those things yourself. And it can be, let's say that you are handling this exception outside of the function. You have to remember in that case to delete the object, and you might not remember to delete the object. So it's easy for memory leaks to occur. Best practice is to throw stack allocated objects. So best practice is to throw stack allocated objects. And the reason is those will be automatically deallocated by the C++ runtime environment at the appropriate time. So is to throw stack allocated objects because C++ automatically deallocates them. So rather than throwing new bad operator exception, what you really should do is simply throw bad operator exception, and that will create a so-called stack allocated object. So that's the big difference, is to use this best practice right here. Okay. Then just like in Java, you match things according to their types, but C++ has a little more verbose set of types because of its pointer types than Java. So if you throw a stack allocated object matches anything of type T or type T reference or of type const T or of type const T reference. Anything that is heap allocated matches T star and const T star, but does not match T, T, ampersand, or the like. So you have to be careful about that as well. If you throw something off of the heap, so let's say that I've thrown stack exception. If I had down here stack exception star E, that will not match it because it is a different type. A pointer to a type is different than the type itself. So the basic difference is that in order to catch a stack allocated object, it has to be a stack allocated type. To catch a heap allocated object, it needs to be a heap allocated type. Stars are heap allocated types. Ampersands and T by itself are stack allocated types. Is that clear? Because this is one of the things I sometimes get on Piazzas, especially annoying after I tell you not to throw heap allocated objects. Someone on the homework throws a heap allocated object, then tries to catch it using stack exception E and wonders why it's not being caught. Okay, the reason is the types don't match. Okay, and then just like in C++, it will also catch, it will also match superclasses. So any superclass of T matches. Okay, and the same thing here, I believe, is that any superclass of T star. So down here, stack is, I made a mistake, and the mistake is there needs to be a public exception right there so that it actually is a subclass of exception. I will fix that. And in that case, C and D right here catch that exception. Okay, and again, I'm going from more restrictive to less restrictive. Now, this one will never be executed. Does anyone know why? Why will this one, if this is the order of the catch clauses, why will B never be executed? Pardon? Yes, because anything that matches B also matches A. They're the same type to the C++ compiler. Whether you're passing it by reference or not, or passing it by value, they both match. Okay? So also C and D would never execute, again, because A would match before C and D. Is that clear? Because that might make a good test question. Okay. Now, the next thing that's important is that when you throw something, you should catch it. When you throw a stack allocated object, you should catch it with a reference parameter rather than with a value parameter. So that's why I say this is wrong, because this is a value parameter. Okay, and this is correct because it's a reference parameter. And the reason it matters is when you decide to rethrow. So sometimes you'll handle an exception and then you want to rethrow it. When you rethrow it, it's different than in Java because, does anyone see the difference? You may not have really caught what a rethrow in Java looked like, but does anyone, there is a difference between Java and C++ in the rethrow. Very good. You got it. This throw doesn't throw anything. So rethrows in C++ don't throw anything. Whereas in Java, they have to rethrow the object, the exception. So rethrows in C++ don't throw anything. There's no argument to that throw operator in the rethrow. So C++ needs to know on its own what's it's going to throw. What it throws is a copy. If this came in as E, it throws a copy of E. If you modified E, if you did E.setValue here, the throw loses this 10. So in this case, the 10 gets lost. Because what gets modified is this copy of E, and the rethrow throws another copy. Rethrow throws the original copy. So it doesn't throw what you modified, it throws the original copy. So if you want this set value to be carried with the object, you need to pass it by reference. That tells C++ that rather than rethrowing a copy, it should rethrow the original object which you have modified. So when you catch things in C++, use a reference parameter. Okay? And if you don't plan to change it, just put a const there. And then it won't get, it tells the compiler you're not changing it. Okay? There's an advantage to that too. Even if you don't change it, why does it, based on what I just told you, why does it make sense to declare it as a reference parameter? Even if I don't intend to change it, but I do intend to rethrow it. Very good. Because you don't have to copy it. Copying wastes time and space. Okay? If you're passing it by reference, you always pass the same object. You just pass a 4-byte or 8-point pointer. But if you're passing by value and you rethrow, it will call the copy constructor. It will make a copy of the original object, and then it will throw that entire object. That's expensive. Okay, so that's another reason you throw it. Efficiency is one. Two, so that changes to the exception object are viewable when it's rethrown. So there's two reasons why you should always catch by reference. Okay, questions about that? Yes? Because you use a dot operator with reference. With pointers, you use the arrow operator. By reference, you use the dot operator. Okay, that's all I can say. By definition, when you use the reference operator, it's a dot. When you use an heap allocated object, it is an arrow. I guess the reason technically is that A reference parameter is technically to a stack allocated object, and stack allocated objects always use the dot operator. Other questions? Okay. Think. So you can throw, let's see, just like in C++, you don't have to handle the throw in the function. If it's not handled in the function, it's thrown up the call chain. So here where I call F, F calls G, G calls, and then in G we throw the exception. G doesn't handle the exception, so it gets thrown back to F. F doesn't handle the exception, so it gets thrown back to main. Now, here is why you use exceptions and not exit. This is important. It's so important, I'll probably put it on the test. Up until now, you probably used exit to exit a program. Let's say that you still think this is a catastrophic exception and you want to exit no matter what. Why is it bad to call exit? The reason is that your program may have allocated resources. If you use exceptions and you handle the exception in main, if nothing else, just catching it and doing nothing, the stack will be unwound. And when the stack is unwound, all stack allocated objects will have their destructors called. And those destructors have an opportunity to free up resources. Okay? And if the resource is in an inconsistent state, you can take an action such as deleting the resource. Okay? Whereas if you simply exit, the stack is not unwound, and all of those partially created resources are left as zombies. And that's bad. Okay? So the reason not to call exit is because it leaves partially allocated or partially formed resources as zombies. Okay? Whereas if you handle the exception, in main, even if you do nothing, if all you do is put empty braces, the stack is unwound. Stack allocated objects are deallocated. Uh-oh. Their constructors are called destructors. So their destructors are called. And the resources can be appropriately dealt with. So that's why you're supposed to use exception handling rather than exit. Okay, exit is actually considered a very bad thing to do from deep in your program. It is much better to use C++'s exception handling mechanism. I doubt anyone has ever told you that. I'm just curious, has anyone ever told you that in any of your classes, how bad exit is? Okay. Well, exit is considered to be pretty awful. It's okay to call it from the handler. Okay, it's okay to do it from there, but that's because you've already unwound everything. Yes?
So, I guess just to understand better, normally the operating system would clean up these partially allocated resources.
It might or it might not. You don't know how it's doing it. You don't know how it's cleaning them up. Let's say you wanted the resource to be actually, it was fine to be partially created, and the operating system actually deletes it. That's no good. You actually wanted that resource to be saved. So you're going to be pretty unhappy about the fact that the resource wasn't saved. So what you're doing is leaving yourself to the tender mercies of the operating system rather than getting to define policy yourself, okay? So that's the issue, is you're leaving yourself to the tender mercies of the operating systems, and not every operating system does the same thing with those resources. If you want yourself to be portable across Macintoshes, Linux, Unix, Mac Windows, Google Chrome, the operating systems are going to have different ways of what they do with those resources. So you shouldn't be leaving it up to the operating system is the bottom line. That's why it's bad. Okay. Other questions? Okay. Like I said, this is so important. I can pretty much guarantee you there will be a test question that asks you why exit is bad. Okay? Because it is. You should not be using it. And as I said, I don't think anyone has ever, I think all the code you have seen up to this point essentially uses exit. Okay. Okay. Some other quick design choices. There is actually an exception class in C++, just like there is an exception class in Java. But it seems people aren't as consistent about using it. Unlike Java, exceptions are not checked. Okay, these are not checked by the compiler. So whether you handle them or not, the compiler doesn't care. That's C++ for you. And you can say, you're allowed to say that you are throwing an exception out of a function with the throw statement, but it was deprecated in C11. So in fact, the C++ standard people decided it was such a pain in the neck, they eliminated the throw statement for a function. In fact, you are no longer supposed to say things like int get value or int pop throws empty stack exception. You're not supposed to do that anymore. It's been deprecated. Okay, so it's actually considered bad form to use the throw statement that way. So in fact, no exceptions are checked. There is a method in the exception class that is supposed to return an error message indicating what the exception type is. Does anyone know in Java what the two methods are that do the same thing? Okay, it defines three methods. In Java, the comparable methods are getMessage and toString. Okay, and Java has a third method, which is printStackTrace, which prints the stack trace. Yes. They could be, but it's typically, from what I understand, not supposed to be. So it's a little unclear to me. I guess they could be, but I'm not ever been clear. I've never seen a good rationale for why they should be different, which does lead me to why they even bothered to define that, but they did. Okay, at any rate, those are the methods in Java. And then there are some methods or exceptions that are subclasses of the exception class. So you may have wondered why you never look at the return type. In malloc, you always look at the return type, right, to see whether it returns 0 for those of you writing C code this semester. When you see malloc, you always look to see whether malloc returned 0, correct? Or you're supposed to. Okay? It turns out you never check to see whether the new operator returns 0. The reason is it doesn't. it doesn't have a return type. If the new operator fails, it actually throws a bad alloc exception. So if the heap is full, it actually throws a bad alloc exception. You can actually catch that. You probably didn't know that either. But that's why new, you're never checking the return value. The reason is there is no return value. It throws an exception if it fails. Okay? If you try, there are such a thing called dynamic casts. That's not, this is not a dynamic cast. There is actually a cast, off the top of my head, I forget it, but it's something like dynamic cast or something. I would have to look it up. But it's actually an operator. And if you call dynamic cast and it turns out that the type of A is not an int, then you'd get a bad cast. Okay, you can catch arithmetic errors. Okay, you can get certain errors from vectors. You cannot get you cannot catch signals. Okay, so if you think that you can catch seg faults or bus errors, you can't. Okay, system error does not include signals. Signals are what are generated for sig-seg and sig-bus. Those are seg fault is sig-seg v. Bus error is sig-bus. Those are signals. Those are not caught. Those are hardware-generated exceptions. C++ can only handle so-called software-generated exceptions. Okay, so you can't catch those signals. Okay. The last thing is sometimes you will try to throw out of a constructor. So for example, let's say you're creating a dynamic array and you pass in a negative size for the array. That's an error. You can't construct a negative sized array, so you would want to throw out of the constructor in this case. Well, throwing out of the constructor has special ramifications. First of all, the destructor for the object is not called. So if you have already allocated memory, let's say that before you went out, before you called it, you said data equals new int 10, that will not be deleted. So you actually have to delete that yourself because the destructor will not get called for this object. However, destructors for the member objects will get called because they have already been initialized. So any stack allocated objects that are member variables will get called. So if you had something like down here, class stack protected vector data, and then in the constructor you throw an exception, then the destructor for this vector will get called because it was initialized. So in fact, if you have resources that you are allocating, what you are supposed to do is allocate those resources. Okay, actually, there we go. Well, I don't really have it. Basically, if you allocate resources and you throw out of a constructor, you should allocate those resources in stack allocated member variables. Because their destructors will be called. and can deallocate the resources. Okay? So that's pretty important. And finally, the memory for the object that was being constructed will be freed. So when you return from like a new, it will essentially be null because you're throwing out and the memory for the object is automatically freed. So when you throw out of a constructor, if it was being allocated off the heap, it's returned to the heap. And you're thinking, okay, what is the return value if I say A equals new stack, and you're saying what value gets assigned to A? It's a trick question. Why don't I care about the value that gets assigned to A? Why is it irrelevant? It doesn't return, right? What does it do? Well, it throws, so it's not returning to the statement. It's returning to whatever catches the exception that was thrown, so it's never returning to that statement. If you throw out of a constructor, what it's going to return to is whatever catch block catches the exception. This statement will just never finish executing. That's why it was a trick question. It doesn't matter. There is no return value. Nothing gets assigned to A. Whatever was in A before is still in A. It's not 0. If A was equal to some pointer address, that pointer address is still in A. Okay, because you throw out of the constructor, it will be caught in an exception block, and the statement I have underlined will never get completed. Okay. Again, I know this is technical stuff. That's why I'm going over it. Okay, especially because I know some of you won't read my notes. And it's not in, I mean, I had to go onto the internet and because I was playing with it and finding strange anomalous behavior. This isn't like documented very well. That's why I'm going over it. Okay. So, questions about C++ exception handling. Okay, we went over some important things. Why you shouldn't call exit. Okay, why you throw stack allocated objects rather than heap allocated objects. Why when you catch by reference rather than by value. Okay, fourth, why it is a little dangerous to throw out of a constructor, and when you do throw out of a constructor that you should be allocating resources using stack allocated member variables so they can get cleaned up. Okay, so those are 4 pretty important things that are different from Java. Okay, and then some minor things such as when you rethrow, there is no argument you provide to rethrow. Also minor, but something that you definitely should know, the new operator, the reason it does not have a return type is because it actually throws a bad alloc exception if it fails. Yes?
Doesn't new return the pointer?
If it succeeds. But if it fails, it throws, and again, the assignment's never completed because it has to either be caught or in most cases, I can guarantee you, since none of you knew about bad alloc, none of you were catching it. So your programs were simply exiting because main eventually threw it out to the C++ runtime environment, and the C++ runtime environment prints an error message. Okay? We good? Okay, I'm not going to spend a lot of time on exception handling in C because for the most part you already know about it. Either because you're taking 360 or because in 102 and 140 we showed you some rudimentary ways to do stuff. I do want to point out that with an exception, It is an unusual event, but it's not necessarily an error event. You probably think an exception is an error, but end of file is actually considered an exception in some cases, and that is not an error. Okay, so I just want to point out, most of the time it is true that an exception is an error, but it's just a special situation. It doesn't necessarily mean it's an error. End of file is a special situation that's not an error. Okay, in C++, some functions, malloc for example, return status codes when there is an error. But I'm sure it's been explained to you, what is the problem with returning a status code from a function? Like an integer status code.
You have to check within the rest of your code, so it can't be.
That's one problem, but more fundamentally. Let's say that it's pop, and pop is returning a string. Wants to return a string value.
So returning matches.
Pardon?
The returning isn't the right kind of variable.
It's not the right kind of thing. In effect, you want to return values. Pop, if you want your function to return a value, you can't really have it also return an error value. Unless you get lucky and it's an integer like malloc, and then you can return 0 if it fails and a pointer address if it succeeds. But in a lot of cases, you can't return an error indicator if you want to return something that is a value. If I'm popping strings off of a stack, I can't return an integer value because functions are only allowed to return one type. They're not allowed to return multiple types. At least I've never seen it. Have any of you ever seen a function in C return multiple types? No, it's impossible. So the big problem with having a function return a status flag is if your function wants to return another type of value, there's a little bit of an issue here. Okay? Plus, of course, you have to check the return values as well, but the big problem is, so then you maybe return it as a pointer variable. That's something you can pass in a pointer, which is a status flag, but that's a pain in the neck. Okay, so another thing you can do is you can actually pass the name of a function to handle the exception. So when the exception happens, the callee calls this function. Okay, the only problem is if there are several exceptions, you have to provide several functions, one for each exception, or that function better handle every possible type of exception. Okay, these functions mimic exception handlers. Okay, essentially there would be one function per exception handler. So C++ and Java simply cleaned it up and separated it out at the bottom of a try statement. Okay, 360, you will learn about set jump and long jump. Those in 360, have you learned about set jump and long jump yet? Not yet. But if you took it, you did. Okay, eventually you're going to get to set jump and long jump if you take 360. So what you can do is there's a command in C called set jump, JMP, that's not a typo. And you pass it a chunk of memory. So buffer is a variable, it's a chunk of memory, and in fact is a pointer. And the set jump allocates enough memory to hold things like the registers, the current program counter, the stack pointer, the frame pointer. So it allocates a bunch of memory big enough to hold all that stuff, and it returns a pointer in buffer. And then the first time set jump is returned, it returns false. Okay, so what you do, set jump saves program state. Okay, then if not result, so the first time set jump is called, it returns 0. So the first time through, this is true, so you end up executing your protected code. If at some point you find an error, you can call long jump, with the buffer pointer and an error code. When you call long jump, the operating system restores the program state to whatever is stored in buffer, which specifically means it restores the program counter so that it returns right there, except that the value that now gets returned is, anyone know who has seen long jump? What's the return value now? No, it's not 0. Very good. It's the error code. The return value is the error code. Okay, if it returned 0, you would get into an infinite loop. Why would you get into an infinite loop if it returned 0? Because it would keep going back and executing the protected code. So actually, when you call long jump, you pass back an error code and then you do some handling. If nothing happens and all is good, you just come out of it and eventually execution gets to this point and you resume execution down there. So you only get back to this result if long jump gets called, the error code gets stored in result, this else statement is now executed, and you do your error handling. In 360, did they tell you what is so dangerous about set jump, long jump? Or my brother, who works for Synopsys, calls his brother, who does know, because he's been having this problem that no one ever told him about. Do you know what the problem is?
Dr. Flink told us about it, but I'm trying to recall the exact specifics of
Okay.
what's going on.
So what happens is set jump tosses all of the nested stack frames when it restores the old values. That means that anything in those stack frames that was supposed to be stored back into memory but is being temporarily held in a variable is lost. So if somewhere in one of those intermediate functions, let's say you tossed out of F back to main, but in G you had some reference, so G had int A is a reference variable, it set A to 10 before it called F. But A was stored in a register, which is very common. Often only when a function returns are the variables written out from a register into memory. Okay, often they're held in registers temporarily. They're not written back into memory because that costs time. When you toss the stack frames, you toss those registers, which means the assignment of 10 to A never happened even though it was supposed to. It means when you get back to main, you expect A to be 10, but it's not. That's what hit my brother about 15 years ago. Fortunately, I knew the answer. Okay, that's what was happening. I asked him immediately, did you call long jump? And he said yes. And I knew immediately what had happened. So there's a way to combat that, which is you declare variables volatile. When you declare them volatile, it forces C to write those variables out to memory immediately. It can keep them in register, but it also must immediately write through to memory so that the save is permanent, or the change is permanently made. So if you declared that A to be volatile int A, then the value would always be written through to memory. Okay, so that in fact fixed my brother's problem. He declared the appropriate variable volatile. It fixed it. Thanks, big bro. I felt pretty good because it was one time when the academician knew something someone in the industry didn't. So pretty cool. So at any rate, the problem with volatile is it slows everything down. Every time you write through to memory, that stalls the pipeline, okay? And it takes cycles. So today's processors are pipelined, very efficient. When you write through to memory, it messes them up. So the problem with volatile is while it forces a change to be made permanent, at least in memory, it slows down the execution of your program. So you need to be, that's why set jump, long jump aren't so good. Remember that with the exception handling in C++ and Java, they do unwind the stack. Okay? They do unwind the stack. Okay, the final way that you can handle exceptions in C++ or in C, and actually in C++ as well, is you are allowed to actually handle signals generated by the hardware. Why you would ever do this beats me, but Dr. Planck probably knows a reason that I don't. But you actually are allowed to catch sig, seg, v, and sig, bus, and other errors. The way you do it is with the signal command. You give the code for that signal and a function pointer to the function that will handle it. The function takes as its argument the number of the signal, and it does whatever it's supposed to do. When it returns, it tries to re-execute the instruction that caused the signal. That's the problem. If you can't fix that seg fault, it will seg fault all over again, and you'll get into an infinite recursion where the seg fault gets generated, your signal handler gets called, it's not able to patch the seg fault. So in this case, what I'm doing here, that would get me into an infinite recursion. That's not fixing the seg fault. It will re-execute whatever code caused the seg fault. Another seg fault gets raised. My signal handler gets called. It prints out sig seg. Gee, thanks. Got it. For the 100 millionth time, I got it. Okay, so that's why I said I can't imagine why you actually would try to handle them. I understand in the operating system why it would. The operating system doesn't want to shut down. The operating system wants to do something like terminate your program. So the operating system has a good reason to catch signals. You don't. But I'm just telling you that it is possible. That is a fourth way to handle exceptions in C. Questions about that? Okay. Big deep breath. We are done with exception handling. We in fact are done with many of the language features. So again, there were 4 language features we went over: inheritance, modules, exception handling, generics, how to create them, that many of you had not seen before. So part of 365 is talking about language mechanisms that you may not have been familiar with, and to make you familiar with them. Okay. For the next, we're a little less than halfway through the course. We're now going to go a little bit more, as I said, toward system stuff, because not only are we going to talk about information management, we're also going to talk about concurrency in a few weeks, and that's also kind of a systemsy concept. We'll also be talking about scripting languages and functional languages the rest of the way, so those will be the 4 remaining topics. Okay, so information management, pretty important in today's world. We're not going to talk about information security. You all don't, but as part of the ABET revamp, security is now required as a course. So starting in the fall, there is going to be a required security course at 300 level that all people starting with catalog year 2019-20 will have to take. And that course will cover information security. So we're not going to talk about information security in this course. This course, information management, what we care about is essentially these four things. How you acquire information, that's content capture. How you manage and store it on devices. Okay? How you analyze it. So how you use that information. C, content analysis, is how you use that information. And then how you present that processing to the user, typically visually. So there's 4 aspects of information management. How you acquire the data, and there's different ways. Someone may give you a bunch of old photos or a bunch of old diaries from the Civil War. That's information capture. Or maybe you have sensors that are capturing an information feed from a nuclear power plant. Or maybe the sensor is out in the wild and it's taking photos of animals as they pass by the camera. Those are all capture. Or maybe you're at a recording session. You're musicians and you're jamming. That's information capture when you capture. Right now, with Camtasia, I'm recording this lecture. That's content capture. Okay? Then how we store it. Do you store it in the cloud? Do you store it locally? Okay, how you store it, on a database or a NoSQL database. Then how you analyze it. Do you use data mining on it? Do you use some pattern recognition techniques? Maybe it's a spreadsheet. Actually, spreadsheets are considered information management. In spreadsheets, it's constraint solving. Okay, and how you present it to the user, often through visualizations. We'll see that the primary human sensory for input is the eye, by an order of magnitude over, which do you think is number 2? Your ear. Yep. Number 3? It's actually no, smell. Yep. It's over, you're right. Number 4 is your skin. So that's pretty much the order it goes. So almost all output from a computer is visual because that's our primary sensory channel. Audio is supportive, and obviously if you are visually challenged, then audio becomes your primary, typically, means of communication. Okay. So content capture. It involves certain things. First of all, you have to digitize it. Okay, so because if I give you an old photo, that's not digitized. I may be playing an instrument and doing a brilliant job, but that's an analog signal. That's not digitized. So you have to figure out how to digitize it. The way you digitize that stuff is sampling, because you have to break a continuous signal into a discrete signal, okay? A discrete set of information. I can't store a photo. It's going to be pixels that I store. If I'm playing music, I can't store the entire music signal. I'm going to have to sample it. Anyone in here a musician? Do you know what the sampling rates are? I just took it off.
44.1 kilohertz.
Yep, you're right there. It's 44.1 and 48, meaning that's how many times you sample. So with sound, typically there's 48,000 samples per second. Whereas with video, believe it or not, 30 samples per second is good enough for rather static scenes. 60 is better for high motion. So sports or for motion pictures, they typically do it at 60 frames per second. But it turns out the human eye at roughly 20 to 30 frames per second views it as continuous motion. Yes? I read 60. If I'm wrong, I will check it. Okay? So that's what I'd read, but I'll check it again. You think there's...
I think that a lot of people who do things on YouTube nowadays go for 30 or 60. But if I remember correctly, a big deal was made about The Hobbit because movies for a long time used 24, and then The Hobbit ended up like a really big file because they went with 48.
Okay.
Movies are behind for some reason.
24 is
Okay.
standard since 1927.
Yeah.
Interesting.
It's different
Okay.
for people on the internet.
So I'll look at that and see why I had movies at 60 frames per second. So there you go, though. What I said, 20 to 30 frames per second, the motion picture industry is banking on the fact that your eye at 24 sees it as continuous. Okay? And then the Library of Congress suggests, I told you you're not going to find this everywhere. I did a lot of preparation for this one. If you're sampling old photographs, they suggest 300 dots per inch. They say on some of them they go up to 400 dots per inch, but they typically suggest sampling at 300 dots per inch. So at any rate, the goal is to create a signal that is not perceptibly different than the analog signal. There was a big debate when CDs first came out as to whether they were cutting out what were supposed to be the high-pitched things, the high-pitched noises, And there was a debate among connoisseurs as to whether records really were better than CDs. They claimed they could hear the omissions. Experts scoffed and said the human ear could not hear it at those ranges. So take it for what it is. If you're a audiophile and you think records are better, I won't argue it with you. But the claim is that the human ear is really not able to hear sounds above a certain frequency or below a certain frequency, and that at 48K, you're not missing anything. Okay, but there are some people who claim otherwise. Okay, Hobbit. Apropos, the file was enormous. So compression often has to come in because even after you sample, the file still may be too large. So you compress it using some algorithms, and there are two types of compression. Lossless compression actually completely preserves it, so nothing is lost, but it simply is able to compress it. I'll tell you how in a moment. Lossy compression actually loses some stuff. JPEG is a lossy compression. So you lose some things. They're just trying to lose stuff that they think is insignificant or imperceptible. Not always imperceptible, however. So sometimes in JPEGs you get artifacts because they're losing stuff. Okay? Then sometimes you have to transform information from one format to another before it's usable. That's true with sensors. Stuff that comes in a sensor may not be in a format yet that's usable. You may have to convert it, for example, to a .xls file if you want to use it in a spreadsheet. Or for those of you who think Microsoft is the demon and they use OpenOffice, and you send the file to me, I don't use OpenOffice, so I have to transform it. So that's what transformation and translation is all about, is sometimes it's not in the right format. Migration. Most of you encounter this at some point. For example, you move to a new computer, or the device simply becomes old. Okay, so if you want to preserve it, you either, well, there's two options. You don't preserve it, over to the trash can. That's migration. Okay, it's deletion, but it is migration. Okay, to the landfill. Or it is, you have to find a way to transfer it to a new medium. Now that's different. Here we're talking about translating between two roughly equivalent technologies. Migration means from something that's obsolete to something more modern. Okay, that's the difference. And then this one actually comes under two categories. So crawling and harvesting means you're trying to summarize a data set. You're going through the data set, you're extracting meta information from it. So you're indexing it. Okay, that's what Google does. Basically crawls the internet, extracts information. So this is content capture for Google, because without doing it, Google has nothing. So for Google, this kind of crawling is content capture. But if you already have that information, let's say you're a librarian, you already have that information and you're crawling it to create a catalog, then it falls under the category of content analysis. So this is kind of, you can argue, depending on how crawling and harvesting is being used, it's either content capture or it's actually using the information, it's processing it. So I actually have crawling and harvesting also done down under content analysis. Okay, so it wears two different hats. Okay, so questions about content capture. Those are the big issues. Basically, the big issues are sampling and compression. Okay. Then, once you have captured it, you have to figure out how to store it and manage it. So, storing, there's two options these days, local or cloud storage. Okay, local, I think we all know, cloud storage, you give it to Google or Amazon or Dropbox. It's somewhere in a data warehouse, but not on your computer. It's on someone's server farm. That's cloud storage. Okay, well, does anyone need me to explain anything more about cloud storage? This isn't really a cloud class. Okay, just so you know, if it's on your local computer, it's a lot more secure, harder for hackers to get at it typically, and it's rapidly accessible because you only have to get it from the disk. The bus that takes it from the disk to the CPU is pretty fast. But it could be hard to share. That's why Dropbox was invented, so you could share your photos and other things. It tends to be more expensive because you don't necessarily use all that storage immediately. And you have to deal with migrating that information when you upgrade to new devices. If you put it in the cloud, those disadvantages go away. It's easy to share it. All those cloud storage companies give you file permissions so you can make your files world readable or readable to a certain set of people. So cloud storage makes it easy to share things. It's less expensive in the cloud because they're aggregating all their storage over everyone, so they don't have all this unused storage. Okay, and they do the migration for you. They deal with migration rather than you. So they're doing it as well, just you don't have to worry about it. Okay, disadvantages. Okay, it tends to, it's less secure. Okay, much more subject to hacking attacks. Okay, at one point I just read the Chinese hackers managed to reroute some data that was flowing somewhere through Chinese servers. You might not like that. If you have certain bank information or the like, it may not make you feel warm and fuzzy to know it's going through Chinese servers before it gets to wherever you meant to send it. Okay, so it's certainly less secure. Okay, hopefully none of you are criminals, but it is easier for the government to see stuff in cloud storage than it is in your house. You even get one last effort to smash it or to blow it up before as the people come in, so it is less secure. And the access is less rapid because not only does it require a read from some device, but it has to be transmitted over the internet. Because it has to be transmitted over the internet, it could be unavailable to you if you don't have an internet connection. Okay, so those are some disadvantages of cloud storage. Okay, probably pretty obvious, but nonetheless. Okay, compression. I'm not going to go through the algorithms. Okay, I'm sure there's a course somewhere, somehow that does it here, but it's the mathematicians who develop these compression algorithms. The lossless ones, they can do some cool things, but here's just a really simple example. Suppose you have a string of 100 zeros. Super easy compression. Replace that with 100-0. That's 5 bytes rather than 100. Okay, so that's a very simple form of lossless compression. Okay, there's certainly more sophisticated types, but I won't go over them with you. Lossy compression. These are so sophisticated that they are proprietary often because people spend a lot of time coming up with good lossy algorithms that compress the image without losing a lot of important information. But what is important is the secret sauce, right? That's what makes them proprietary. So they get even smaller images than lossless. So lossy is smaller than lossless in terms of both size and image quality, because you obviously lose something, or quality. I'll just say quality because it can be audio quality as well. So quality is also less. Obviously, it's a trade-off between size and quality. Okay, and if you repeatedly save an image in a lossy format, meaning if you save a JPEG again, it will actually be worse. It will keep losing information each time you save it. Because the second time you try to save that JPEG file, it will take that JPEG file as the original file. and it will try to compress it further, and it will succeed. So the image will be even worse, but it will be smaller. Okay, you'll hear the terms codec and container. Codec is the algorithm used for encoding and decoding the data. The container is the file that holds the data. Pretty simple, but you will hear those two terms. Okay, storage formats. You probably never thought plain text was very difficult, and it's not, but there are a couple things you should know. First of all, there are two common standards, ASCII and Unicode. Okay, ASCII is what you're familiar with when you're using Unix, but the web and Java tend to use Unicode. Well, Java does use Unicode. Page content on the web tends to use Unicode as opposed to ASCII. Okay, believe it or not, text files do not come with an encoding, meaning when a program opens a text file, there is nothing that says it is encoded with ASCII or it is encoded as Unicode. The file makes or the program that reads it makes an educated guess. Okay, it turns out they're sufficiently different that they almost 99.99% of the time they guess right. But the encoding is not actually there. They don't tell you what it is. ASCII, you should know it, 7-bit, 128 character code. Clear drawback, it's English. Okay, it can't store multilingual characters. Okay, you might think the reason they used 7 bits was so they could use the 8th one as parity. You would be wrong. They just wanted to save storage. Okay, so it just made it more compact. They only needed 128, so they used 128. Okay, in the early 90s, as Java came in and the web came in, people said ASCII's too English-centric. We need something that can store different language characters, also things that are graphemes, okay? Or kanji or Chinese characters. So they developed Unicode. At this point, it has that many, over 1 million different codes. They're called code points. If you're going to call them character codes, fine. I'm not going to be upset. They like to call them code points because sometimes it's not a character, it's a so-called grapheme. It's like an emoji, okay? So it doesn't have to be actually a character. The first 128 code points in Unicode mimic ASCII. Okay, now, this is important. You may think, you probably have heard of UTF-8, UTF-16, and UTF-32. And you might think, oh, that's Unicode. Not quite. Unicode is different. UTF-8, 16, and 32 are encoding techniques. Okay? They're encoding for Unicode because a Unicode code point requires 3 bytes. But you can encode the lower ones more efficiently. So for example, UTF-8, which is the most common encoding in use today, including on the web. I'll finish up. I know it's 1:55. I'm just going to finish up the 3 encodings. It'll be quick. It can encode all ASCII characters in 1 byte. Okay? It starts the first byte with 0, and that means it's doing the encoding all in 1 byte. If it needs 2 bytes, it starts the first byte with 110. The second byte starts with 10. The actual character codes are then contained in the 5x's here and the 6x's there. If it needs 3 bytes, it uses 1110 to start and then 2 more. If it needs 4 bytes, it starts with 4 ones. But always by looking at the first byte, the decoder knows how many bytes are encoded here. So this is in effect a lossless compression. You're wondering what's a more sophisticated lossless compression? UTF-8 is lossless compression for Unicode. Okay? So, I'll come up, okay. So it is lossless. These are what the encodings look like. So it always can look at the first byte. 0 is 1 byte, 110 is 2 bytes, 3 ones is 3 bytes, 4 ones, 4 bytes. Okay, UTF-16 used internally in Windows and Java and JavaScript, but it never caught on the web. UTF-32, very simple 32-bit encoding, no compression, much faster for decompression, but also much bigger, very rarely used. So now you know what UTF-8, UTF-16, and UTF-32 are. For today's quiz, make sure that you go through my document formats and my audio and image formats. Believe me, it's not tough. You can read it. I don't need to bore you with it. You can stop when you get ways to store content. I will go pick up with ways to store content on Thursday. I do not need to bore you by telling you all the different common formats that are out there, but read through my notes because I did take some time to put it together. And it's on the quiz. Okay? So I will see you all on Tuesday. Have a great weekend. Hopefully the rain stops. Not forecast to, but you never know. Pardon? Attendance quiz. Thank you. You all are so nice about that. You should tell me at 1:45 to do that. Okay, I need to, as always, move this quiz later. Okay. So the password is rain. All lowercase. Yes. It was rain. It was drumming rain on my roof when I did it. So I'm just changing the due date to make it 2:05. Okay. Y'all are free to go.